Here we have a math Olympiad question. So that is, we have to solve this equation for x. Okay, and my first step, what I'm going to do is, I'm going to divide both sides of the given equation by this stuff 9 to the x power. So let me write the given equation: 2.9 to the x power negative 15 to the x power equals to 25 to the x power. So now I divide both sides by this stuff 9 to the x power. So now 9 to the x power is a common denominator for this one and this one. So this 9 to the x power, this denominator can be taken separately for each term in the numerator. Then I'll be getting 2 times 9 to the x power divided by 9 to the x power negative 15 to the x power divided by 9 to the x power equals to, and here for both numerator and denominator we have the same exponent x. So you can take this x, we can take the exponent x in common. So then I'll be getting 25 over 9 whole to the power x. So I have taken this exponent x in common. Okay, here this 9 to the x power, 9 to the x power will cancel out, and I'm just getting 2 over here. And here also the same thing. We have the same exponent for both numerator and denominator. We can write this exponent in common. So in that case, I'll be getting 15 over 9 to the x power equals to, so this 25 over 9 can be written as 5 over 3 the whole square whole to the x power, because if I apply this exponent 2 for this 5 it will become 25. So here when I apply the exponent 2 for 3 it will become 9. Okay, here this 15 over 9 can be simplified. 3 goes into 15 5 times and 3 goes into 9 thrice. So I get 2 negative 5 over 3 whole to the x power. And here the base is 5 over 3. We have an exponent 2. And for this complete stuff, again we have an exponent. So whenever we have two exponents like this, we can switch these two exponents. So if I switch these two exponents, I'll be getting 5 over 3 to the power of x whole square. I just switch the two exponents. So here I have 5 over 3 whole to the power of x. Here I have 5 over 3 whole to the power of x. So now I'm going to assign a new variable for this one. So to make this solving process easier, that is let y equals to 5 over 3 whole to the power x. So then what we get on the left side is 2 negative. For this complete stuff, we plug in y equals to, for this complete stuff, we can plug in y, and but we have exponent 2 over here, y square. So we can write this, actually this is a quadratic equation. We can write this quadratic equation in the form a y square positive by positive c equals to 0. So when I write this one in this form, so I'll be getting y square positive y negative 2 equals to 0. So I have to solve this quadratic equation for y. So here the coefficient of y square is 1. Actually, we don't have any number in front of y square. So I have to assume there is 1. So in that case, let's take the constant term, negative 2. Now get two factors for negative 2. So that the product of the two factors is equal to negative 2, and the sum of the two factors must be equal to the coefficient of y. So we get positive 2, negative 1. So these two factors will work. When I multiply these two factors, positive and negative 1, it will be negative 2. When I add them, it is positive 1, which is the coefficient of y over here. So even from these two factors, we will be able to get the values of y. So that is, we just have to change the signs of these two factors. So then I get y equals to negative 2 or y equals to positive 1. Okay, actually y is a variable, it was taken by us, so it has to be replaced by the original stuff. We know that y equals to 5 over 3 whole to the power x. So we can replace y by the original stuff 5 over 3 whole to the power of x. Then we get the first equation is 5 over 3 whole to the power of x equals to negative 2. And if I replace this y by 5 over 3 whole to the power of x, I'll be getting 5 over 3 whole to the power of x equals to 1. Okay, here, so whatever value we have for exponent x, so it can never be negative because this value is positive. So for positive value, if I take any exponent, positive exponent or negative exponent, so the result of this expression is always positive, but on the right side we have negative. So we can reject this equation. So logically it is incorrect. Okay, let's consider this one over here. So here 5 over 3 has to be raised to what power so that it has to be equal to 1. It's very simple. The exponent of x has to be 0, because already we know that for any non-zero number, if the exponent is 0, it must be equal to 1. That is 5 over 3 whole to the power of 0. So 5 over 3 is a non-zero number. I am raising this non-zero number to the power of 0. So what is the result? It's just 1. So if this result, I mean, the value of this one is equal to 1, then the exponent has to be 0. So the exponent we have x, so x has to be 0.